Students, in this video I will be going through some exercises with you where I will be attempting to find the volume and surface area of these composite figures. And all answers must be expressed in terms of pi or reduced fractions. The instructions here also says to specify your final answer in terms of a whole number. I will not be doing that. However, if you want to confirm the answers, I already have the solutions written up in separate documents, so you can definitely check that out and to verify your answer. But in the video, as I go through this, I'm not going to go through with entering anything into the calculator. Alright, so a couple of things really important, okay? Some formulas that we will be using for this exercise is the following. The volume, just zoom in here. The volume of a cone is given by 1/3 pi r squared h. The surface area of a cone is given by pi r times L, where L is what's called the lateral edge. And if you're wondering, what is that? So let me just draw it out for you guys. Okay, in any cone, or right circular cone for that matter, okay, there's always going to be a height, and the height is always going to be from the very tip down to the base. Okay, the radius of the base is from the center to the edge of the circle, and then this guy right here, that's called the lateral edge. Okay, all right, and then the volume of a cylinder is given by pi r squared h. The surface area of a cylinder is given by 2 pi r h. This is the lateral area plus 2 pi r squared, because there's a top and bottom, right? And actually, you know what? I forgot this guy. It should be plus pi r squared, because there is a the bottom side of the cone. Okay, and the sphere, volume of a sphere, is equal to 4/3 pi r squared, pi r cubed rather, and the surface area of a sphere is equal to 4 pi r squared. So here are all the formulas that we will be needing for this. So let's take a look. First, I'm going to find the volume of these things. So looking at this, and it looks like I did not overdimension. Sometimes I get a little overly zealous, okay? That height of the cone there has to be 3. If the height is 3, and if you look at this, this forms a right triangle. This is a right triangle here. If that's a right triangle there, then that means, the base of that triangle must be 4, which means also the radius must be 4. So the volume of this thing is the volume of the cylinder plus the volume of the cone. So the volume of the cylinder is pi times 4 squared times h, which is 3, plus the volume of the cone, which is 1/3 pi r, which is 4, square times 3. And to simplify all this out, 16 times 3 is 48, so it's 48 pi plus 16 pi. This leaves me with 64 pi. inches cubed. That's the volume of this thing. The surface area, what will that be? So the surface area is, I'm dealing with the right cone above, so it's going to be pi times 4 times the lateral edge, which is 5. I do not add the circular base until I get to the cylinder, which is going to give me a lateral area of 2 pi times 4 times 3 plus the area of the base, which is pi times 4 squared. And then adding all of this stuff up, or simplifying all of this, this is 20 pi plus 2 times 4 times 3, that's 24 pi plus 16 pi. I can now combine all of this together. 24 plus 16, that's 40. 40 plus 20 is 60 pi inches squared. That's the surface area. Okay, moving on. All right, so the radius of the sphere above has to have a length of 1. And if that's a length of 1, that means the diameter of the cylinder must be 2. So the volume of this is going to be the volume of the hemisphere plus the volume of the cylinder. So the volume of the hemisphere is going to be half of 4/3, or in other words, it's 2/3. Pi times radius, which is 1 to the third, plus the volume of the cylinder, so it's going to be pi times 1 squared times the height, which is 2. I will end up with 2/3 pi plus 2 pi. I add all this stuff up. I end up with 8/3 pi inches cubed. Surface area will be the area of the hemisphere. So since the full area of a sphere is 4 pi r squared, half of that will be 2. So it's 2 pi times the radius, which is 1 squared, plus the lateral area, which is 2 pi times 1 times the height is 2. That's the area of the lateral edge, right? That's the area of this part right here that I just came up with, right? So that's the area of this. But now I gotta find the area of the base, the bottom. What's the bottom? This is the bottom. So that's pi r squared. And that would be pi times, whoops. That would be pi times r, which is 1 squared. I add all of this stuff, or simplify all of this. This is 2 pi plus 4 pi plus pi. That leaves me with 7 pi inches squared. All right, let's take a look at the last one. I have a half sphere with a cone, with a right cone. All right, so this tells me that this will be a dimension of 2, which means the diameter of the cone and the hemisphere will be 4. So the volume of this thing, of the hemisphere, will be 2/3 pi times r cubed plus 1/3 pi times r squared times h, which is also 2. I simplify this. 2 to the third is 8. 8 times 2 is 16, so 16 thirds pi plus 2 squared is 4. 4 times 2 is 8. 8 thirds pi. 16 thirds plus 8 thirds leaves me with 24 thirds, or 24 divided by 3 is 8. So it's 8 pi inches cubed. So the volume is 8 pi inches cubed. The surface area is equal to the area of the hemisphere. So instead of 4 pi r squared, it's going to be 2 pi r squared. 2 pi r squared plus the lateral area, which is pi times radius is 2 times the lateral edge, which is this length right here going across. So if I know that the radius is 2 and the height here is 2, this must be 2 radical 2 because it's a right triangle there. So pi times radius times the lateral edge is 2 radical 2. This is going to be 8 pi plus 4 radical 2 pi. And I can't go any further because they're not like terms. This is going to be inches squared. And there you have it.